Hello everybody and welcome to CS202 Online. Hope you're all having a wonderful day today. So today we are going to be talking about exception handling. But first we got to finish operator overloading. And so I went ahead and I looked at the assignment and saw which operators are being used in that. So that's kind of what I'm going to use to make sure that I give you examples of all of those at least. So all right, let me look at, so in the assignment, it looks like you're doing post to pre-increment, which is a little bit different, so I should show you. And then you're doing C in and C out. So last time we did C out, which was the stream insertion operator. And we also did an example of two binary operators. We did addition and subtraction. Well, I call them addition and subtraction, but really we did the plus and the minus, which typically mean addition and subtraction, but hey, in the terms of strings, it means concatenation for the plus symbol. So really I should call it the plus operator and not addition operator, I suppose. So I had a meeting right before, so that's why we had a little bit of a late start, but we're all good now. So now I can try and switch to the hold on, there we go. Perfect. So, okay, now the VM is running. Let's go ahead and do a quick review first. Let's look at what we wrote last time, which I think I already uploaded, but if not, I'll upload it after the class. So there's two main ways of overloading operators, and that's doing it as a member function or doing it as a global function. And so the main difference is how you want to deal with binary operators, because with binary operators, by overloading it as a member function, the left-hand side is basically the this pointer, so it's that class type. So if that class type is the left operand in a binary operator, then you can do it as a member function. If it's not, then you can't do it inside of this class. You have to do it either as a global function or go to the class of the left operand. And so in this case, because we were adding two objects of class A, we had the option of doing it either inside or outside. Outside, you do run into a situation that being a global function, it does not have access to private variables. How do we solve that? Well, we solve that by either not making them private, in which case we have no problem, or if they are really private and we don't want to do any hackish things, then we have to make it a friend function. So a friend function is a function that has access to private variables with the class that it's friends with. In this case, we make it a friend of A by writing what looks like a prototype in A that says friend A operator plus. And so that basically is like adding the operator plus function to the friend list of class A. And now it can access its private variables. So there you go. That is how you can access private variables. Friend functions, by the way, again, can be used not just for operator overloading. They can be used anytime you need to access privates. However, I discourage you from just kind of doing them whenever, because there's a reason that you made something private, right? And that's because you really don't want other things messing with it. So you're sort of breaking your own rules when you're using a friend function. So really sit down and figure out why that's the case and whether you should do it or not. Can this be a member function? Because the other part is, one of the things that I mentioned, but I want to emphasize, is that when you're running a global function or a global variable, you're affecting the code of the entire program. So like you're affecting other people's code potentially. So you should either stick to a namespace or stick to a class scope. That way, everything is self-contained. And so with operator overloading, you kind of have to either use a namespace or otherwise then it's global, so it's going to affect everybody else. So you got to be careful about that. So yeah, let's just look at the stream extraction operator, sorry, that's this one here. This is a special case because this one has to use a friend function because the operands are of different types. And so in this case, well, I guess it doesn't have to be if there were no privates inside of A, but there are. And so in this scenario here, the OS stream is going to be your C out, your F out, whatever. And it's a special return type. It has a little reference OS stream in there. And the first parameter is the stream itself. And the second one is what you're trying to basically see out. And so you got to make sure that this parameter here matches what you're putting here. Don't put C out here, otherwise you're hard coding it. It will not work for file streams. Whereas this way, it'll work for file streams without an issue. And so essentially when you do this, now you gotta make sure you return at the end, otherwise the thing crashes, as we actually had happen last class. And once you do that, you can now basically call cout on a object. So as you can see here, you can even do a combination of that here. So let's go ahead and overload the assignment operator for dealing with chatler versus deep copy. That's a good case. And let's overload a couple of other operators. So, okay. I'm going to go ahead and copy the same class A from before, just to save some writing. I don't want to do it in the same file because it's already big, but I kind of just want to build on that previous program. So we're going to keep the, here, let's just copy everything first. And so now I'm going to keep the cout stuff. I'm going to get rid of the addition. I don't really need that one for this one, and it's just taking up space. And I'm going to get rid of the subtraction. And I'm going to clean up my main here. Where are all these X and Y's? Huh, I don't remember making those. I guess I was giving them an example. So yeah, this is a good start like this, okay? Maybe also to just save one extra line of code, I am going to move these to the top. Actually, that one doesn't need to move, but this one does. Here, like that, because that's private by default. And then that doesn't really matter whether it's public or private, as we saw. And then maybe put that here like that. Actually, no, because I got to add in more lines of code. So, okay, this will be a good start. That way, you don't really need to see this when it goes out of the screen. So the first thing let's do is, how about we overload the cin operators, because we'll need that. So actually, before we do that, I want to change how this class works. I want to make it dynamic. So I'm going to make these two dynamic, which does mean that in my constructor here, I can no longer do this. I instead have to do x gets new int, y gets new int. And then now I can go ahead and say x gets x, but I have to do scope resolution operator because of the variable naming. Or I could have also done this like that. This gets x and this y gets y. Okay, that's just because I had the same variable names. If I had something like xx here, then I wouldn't have to worry about that. Okay. So I'm gonna pretty much put this all in one line. And then I don't want to have memory leaks. So, well, I'm gonna put the destructor, but I'm coming it out because otherwise it'll crash, as you'll see in a second. But, and that's kind of what I want to talk about. But yeah, for now, what it would look like eventually will be delete y and delete x. And I guess you don't really have to do that, but I'll do it anyways. Set them to null afterwards to avoid dangling pointers. But again, I'm going to go ahead and comment this out for now. Okay? So before I actually do the cin, let's just make sure this is still running. So let us go ahead and make an object of A, and let's go ahead and fill it out. So actually make it dynamic. That's the whole point of, actually, no, let's not make it dynamic. Yeah, let's make it dynamic for now. And let's put again 2 numbers here. Are those the same numbers as last time? I feel like it, but okay, doesn't matter. And then, yeah, let's just go ahead and say cout A just to make sure that this works. And that's it, okay? Invalid conversion from int. Okay, I forgot the asterisk, yeah. So, asterisk and asterisk to dereference that. Remember, order of precedence means that this goes before that, so I don't need extra parentheses. I could put them, but I would look amateur if I did. So, okay, I suppose I also gotta update the OSStream one, because right now it's just printing out the value of x, but x is a pointer, so what I need is to dereference that. So I can either do that this way, or I can go ahead and use the, actually, yeah. Just dereference it like that. Should be good to go like that. Again, I don't think I need any parentheses for that. Okay, there we go. So it's working fine, right? So now here comes the problem with shallow copying. Oh, doorbell's ringing. Well, hopefully they're delivering something because I am busy. Let me check with my camera really fast. Sorry for that. Just want to make sure that it's like I'm not getting swatted or something. Nope. It does look like a big truck, but it is not a SWAT truck. It is a UPS truck. So I'm good. Okay. So anyways, let us go ahead and make a second object. So in this case, we are going to make A2. Yeah, A2 like that. So I guess we'll call this one A1, just so I don't get confused. Okay. And so what I'm going to do with A2, and I could have done it in the same line, but I'm making it here just to make a point, is I am assigning the value of A1 into A2, right? So normally this would be fine. In fact, I mean, it's currently fine right now if I do this. Like, you will see that A2 and A1 contain the same thing. So like, if I actually put two cout statements, I wonder what they're delivering. Oh, I know what it is. I think I wrote it. Amazon Prime Day. Okay. So as you can see, they both contain the values of 2 and 3 because I copied it. So the thing is, the problem here with the shallow copy being that when you're copying pointers, you're copying the address of the pointer. Therefore, I'm making a shallow copy essentially, and I can prove that to you by changing one of the parameters. Let's change the public one. So let's change x in A2 to be 22. Okay, and that's going to change it for both A1 and A2 because of the shallow copy, as you can see here. Okay, of course that is a problem. So how do we solve shallow copy? Well, we make it a deep copy. We got to make a for loop, etc., right? And so when we talked about that, I showed you how to do that. I even showed you how to do it with the copy constructor, right? But I didn't show it to you with the assignment operator because I said I'd show you that with operator overloading. Well, that time has arrived now. So yeah, let's go ahead and do that. So let us overload the assignment operator. So I'm gonna do it in this case, it doesn't really matter if it's a friend function or not. Member or friend, what should I do that? Well, do you guys have any preference for that? Let's make it a member function because when I do the cin, it's gonna be a friend function. So might as well make this one a member function. I mean, you ideally wanna make them always member functions. You really shouldn't be doing friends if you don't have to. But in this case, I was thinking like which one I can use less space, you know, to put it beneath. So yeah, but in this case, it should be fine either way. So in this case, what does the assignment operator return? So normally the assignment operator is of the form of like, you know, A equals B, something like that, right? So you have a left-hand side and a right-hand side, but really the left-hand side is what is being returned essentially, right? And so it's technically, well, you got to think about a scenario where you use something like this. So A equals B, which equals C. So you can chain these along kind of like plus. So it might serve to make it as a sort of, think of it like a binary operator in a way, but really it's more like a unary operator. Okay? So let's go ahead and do it. By the way, I should also show you how to do the equivalent as well. That might be useful to show as well. Okay. I'm gonna see if I have here some notes. I want to see if there's anything preferred about doing this. Okay, yeah, so I gotta make it a const. So yes, that's what I wanted to check. All right, so this will be a good example of seeing kind of like a unary thing. So in this case, what I'm going to go ahead and do is I am going to write const here. Why is it not writing? Here we go. So it's going to return essentially a constant. This will make sense in a minute. Okay, now what is the type that I'm going to return? Again, I have control over this, but I want to ideally make it the same type as the class. You know, like an object of A returns an object of A with assignment. Otherwise, you're doing weird things. So in this case, it'll be A by reference, kind of like how you're passing the OS stream. And then again, well, here I would just write operator. I was going to write the class name like this, but that's what we're going to do once we put it outside the class. For now, we just go ahead and write operator, assignment, and then you're only going to pass in one thing here, which is the right side, which is again another object of A. Okay? So for now, I'll leave it like that because that's just my prototype, right? Because ideally I want to put it beneath main so that, again, I have more space to write more stuff. So in this case, what it's going to be is const A ampersand. In this case, now we're going to do scope resolution operator because it's a member function. Then we write operator equals. Then we write const A ampersand, and then we're going to call it like a right because it's the right side. Okay. So yes, in this case, what we want to do now is we have to be careful about this, okay? Because what we're trying to do is deep copy, right? So we're trying to say like, you know, allocate a brand new object and then copy everything over to that new object and then return that object, right? But in this case, the object's already made and it's on the left side, okay? So you don't necessarily have to create the new object. It's already been made and its constructor may have already like potentially ran. It may have, but it might not have, okay? So what can happen here is, suppose that I wrote the following line of code. A1 gets A1. That is copying itself, right? And it's okay. That's perfectly valid code. But we got to be careful about this because if we don't think about that special scenario, then we're going to have memory leaks when we're running into ourselves, okay? So because of that sort of iffy situation, we want to put an if statement that says if this is not equal to the right side, to the address of the right side, I suppose. Okay? What this is doing is this is making sure that we're not doing self-assignment. Okay? So this is avoiding self-assignment. So like A equals A kind of thing. Which, if that is the case, then nothing should happen. Like if somebody writes this line of code, nothing should happen because there's nothing being updated. So that is why we want to make sure that we don't do anything if that happens. So we want to put that on the top of your code just to avoid that. What you want to return is a this pointer because you want to return this object back. Okay? And so finally, we got to do the member-wise copy here. So in this case, we would go ahead and do x gets, right, well, this x, and we want to make sure we copy the value itself. This x gets the right x, and then same thing for the y. Okay? So the only thing here is whether or not the constructor has already run. And if it hasn't, then we would have to run it here. So like we would have to do something like this x gets new int, and this y gets new int. However, how can we ensure that that's ran? Well, it should have run because of this here. So I think I'm going to leave it uncommented, but then I'll leave it just in case it doesn't run, okay? It's been a while since I've tried that. So anyways, let's try to compile this and see what kind of errors we get. Invalid conversion from int to this. Oh, yeah, that's right. These are also pointers, so I got to dereference them. All right, because we're copying is the value that it contains, not the pointer itself. And there we go. It is fixed now. But the question is if this is doing some weird memory stuff. So let me go ahead and run value grind. Okay, well that's because I don't have my destructor. But this is where I'll really find out if I made actual copies correctly. See if it segfolds. No, I did a segfold. Sweet. Let me run it normally. Okay, cool. So we're good to go. So I guess I don't need to allocate it here. Perfect, perfect, perfect. Okay, so however, let me leave the destructor uncommented, but get rid of this assignment assignment operator stuff. In that case, it crashes because you try to delete the same memory twice, right? So I want to show you that really fast. So let me comment this out and run it again, and I'll show you that it's sec faults. Well, it should have sec faulted. Why is it not sec faulting? Destructor is running. When they're going out of scope, well, let's see if we get errors on Valgrind. So it's not sec faulting because the system was lucky in that sense, but it is bad. And you can see because Valgrind tells you that there's errors. Probably like a double free or something that it says here. And Val is free, yeah. See? So like it doesn't sec fault, but there's errors. Like legit, there's errors. I'm glad Valgrind can tell us that, because otherwise you'd probably be like, he's lying. But I'm not. It's legit, okay? So anyways, but I actually had to comment out because I thought it would actually fully sec fault, but it didn't. But yes, I'm trying to basically delete something twice. But now that I have my destructor, if I, what did I forget to uncomment? Oh, I forgot this one. If I run it again, this time it runs fine and Valgrind shows no errors or leaks, okay? So why did we need to do this? Because otherwise all we are copying is the pointers. Whereas in this case, we're not copying the pointers, we're pointing what the pointer contains, or what the pointer points to, sorry, what the pointer points to. And so in that case, when we do that, then we can see that now each one's pointing on its own. In fact, if we didn't do this, we would have memory leaks too. So yeah. Anyways, does that make sense with the assignment operator? Again, it's just shallow versus deep copy. If I was an array, then I would need to put a for loop here copying the array over it. In this case, it's a single pointer, well, two of them. So I don't have a loop. But if A had an array in it, then I'd have to put a loop in here to copy each member of the array. And so now, you know, I could even write something probably of this format. See if it works. Actually, I think the C++ does not allow me to do that. Let's see. Oh, I did. Okay, cool. But we got errors. Aha. So this one gave us an error when we did... What did I just do? Okay, so I had it like that. So let me put this one beneath. So this one has now the issue where now I need to put what I had before, which was the new allocations. Gets new int and this y gets new int. So if I put those back in, then I don't have the memory leaks, but I have invalid deleter free. Why would it say that? Maybe... Not sure. I'm not sure as to the why. But I will defer it and say that you guys can figure that out on your own. But for now, let us bring it back to how I had it. It's probably calling the copy constructor, actually. That's what I'm thinking it's doing. It might be that. It might be calling the copy constructor. So if I was to write a copy constructor really fast, that might fix the problem. So if I do a copy constructor, now I have to do x gets new int, y gets new int, and then x gets a dot x, what we referenced, and then y gets a dot y, like that. So x gets a dot x, y gets a dot y. Okay, so make sure that compiles. ISO for business correction of it with no type. Wait, what? Oh, ooh, okay. I put the ampersand in the wrong side. There we go. And then the value conversion from int to infinite. So I screwed up. So x gets a x, y gets a y. Oh, here, right. Also, I put these backwards. Or I put too many of them, I think. There we go. Okay. So this works fine. But now if I try doing the other one, let's see if that fixes that. It's running okay. And it's running on the background. So yay, so that's good. So actually it's interesting. I didn't know that, I guess. But when you're doing it like this, it's not using the assignment operator. It's actually using the copy constructor for that. So like C++ is smart, basically. Well, not C++, the compiler is smart. What it's doing, it's essentially converting this code into this code. Like that, which is like literally what was happening here. So like it's converting it into that. So that's kind of cool that it does that. Like if you don't, I'm glad I actually ran into that, because like you might be like, why is the operator overloading not working? And it's because I guess it's using the copy constructor. So well, this again kind of comes back to the idea of the rule of three, that you gotta update the copy constructor, the operator, the assignment operator, and then the destructor, right? I think those were the three, or unless you do rule of five or whatever. So yeah. So I don't think you're gonna run into this issue when you're doing the assignment, but if you do, then now you know how to fix it. So I'm actually really glad that I ran into that. So I'll leave it like that for now. But I'll leave that as well there, so you can play around with it. So that's pretty cool. I'm actually glad that I was able to figure that out, because I would have been kind of sad if I didn't on the stream. But it is fixed now. So, oof. Dodge that bullet. You guys are very quiet today. I hope I'm actually streaming. So yeah. Okay, so let's see. Let me show you the. Let's do one of the Boolean ones. How about the equality? Let me see if I can find an example of that, because it's been a while since I've done those. Oh, here's the CN. Oh, that one I already know by memory. Well, let's do that one then, I guess. Let's do CN first. So let me. And by the way, the reason I keep running into errors here is because I keep trying to write code that is compressed. Like this is so much cleaner, but unfortunately, because this is how much space we have, I have to really compress this as much as I can. And so such is life. So yeah. Anyways, you know what I can do with this one? I could make it a prototype, but no, actually I can do it on one line. So I'll keep it in here. I'll just really squish it all like that. Okay. So there's that one. Is there anything else I can move? No, that's pretty much it. So what I'll do though is I'll do the CN and then I'll switch to a new file, because we don't need this whole assignment operator stuff for CN. So yeah. Okay. So let's go ahead and do stream insertion. So that's like CN. So, no. That's stream extract. I think I got these flipped, guys. We'll do a quick Google on that. Stream insertion operator. Okay, so stream insertion is the cout, and stream extraction is the cin. Okay, so let me go ahead and write that on the notes, because I always get those. I just call them. I should really stop calling them cin and cout operators, because that's what's probably making me forget. So let me go ahead and write that. Stream insertion is this. So stream. You guys can see what I'm doing. Yeah, stream insertion operator is that one. Confirmed. Okay. And therefore the stream extraction operator is that one. So example of that would be C in X. And then this one would be C out Y. Okay? So yeah, don't be like me. Don't get them mixed up. I should probably put that on the test. That way you guys remember it. So yeah, okay. Well, I'm sure that was actually probably in your 1 through 5 test. And by the way, I'm also going to put here as a reminder that A2, A1. So if I ever write the code, A2 gets A1, that becomes that, okay? Because I'm sure I'll forget that, and that's actually really cool that I figured that out. So yeah, this is definitely something that could be a hard question on a test. So yeah, okay. So I will at some point when the semester ends maybe find a way to send you a copy of this massive notes of PDF that I did, maybe before the final, if you guys remind me, if it's readable, hopefully to you guys. But okay, so now we can just refer to that for the naming convention. So anyways, now looking at this, we are going to actually write the stream extraction operator. That just sounds weird. That does not sound right to me, that one's a stream extraction. But whatever. Who am I to question? So it's basically much the same thing, except this was an IS stream instead of an OS stream. And frankly, that's a better way to remember it. You know, maybe this is why I get it confused, because the fact that I see the word I here like this, you know, means for me insertion, which makes sense, but I guess it's not technically. So the way better to remember it, at least for me, is CN, and this stands for in, and this is for out. In and out, okay? Like the eating place. Oh, do not make that one a constant because we were trying to modify it. Yeah. I mean, yeah, you don't want to make that. You definitely do not want to make that a constant. That would end badly. It's like you make the accessor functions, the getters, you make those constant, but the setters, you know, you don't want to make constant. So yeah. Anyways, that is going to be our function prototype. So now for the friend function, so let's go ahead and put that one like down here. So iStream operator in A. Oh, let me get rid of that. I don't like having. I guess I'll match it. So why not? Okay. So for this one, what you want to think about is, what does it mean to read in to an object of A? Like, does that mean like you're reading in a single number, multiple numbers? Like, what does that mean? So you have to define that. You have to like sit down and decide what that actually means to read that in. In this case, we're going to assume that whenever somebody wants to see in an object of A, they have two numbers, and maybe they are separated by a single space. Okay? You have to decide that. Because then you have to figure out if you want to use getLine or just another like cin statement. Like, you have to decide that ahead of time. Okay? In fact, we could use getLine. We don't use as much getLine as we want to. Here, I'll show you first with the cin, and then we can mess around. Okay, so let's say you want to read in into like AX and AY. And by the way, I'm going to change that because it's pointers. So we want to store it into the value of the pointers, what they're pointing to. So that's pretty much it. Make sure you return the insertion up the stream, so like that, and that's pretty much it. Yeah. So if we want to test this, you know, let's say that we are going to, instead of, well, I guess we can still read it, but here let's throw in a cin into A1, so we can change the contents of that. So if we were to run this again, let me clear the screen. On clear. Somewhere I forgot a semicolon. Line 37. Here. Okay, so let's try 9 space, and then 47. As you can see, we indeed read 9 and 47. And then, of course, he gets changed to 22 because of the stuff we have to need. But the point is that it works, okay? So that's pretty cool. But suppose that we wanted to read in the input like car-based. How about that? Like it splits the input into 2 cars. Like flat out just cars. We could use get car for that. Or maybe we use comma separation. Let's use comma separation because that's the one I was saying. So in that case, we would want to change this from reading in like this. Maybe we say, we can make temporary variables, by the way. So like we can say temp something. We'll store the temp there. We're gonna, yeah, in temp. We'll call it temp. Yeah, just temp. Okay. So then we can do something like get line, and then the is stream, and then where we're storing it, temp, and then the delimiter, which would be the comma. And so in this case, that is going to first read in the first part. So I guess we don't need a temp because we can actually throw it in right here. But maybe we want to do some kind of error checking before. So yeah. So then we can say like if temp is greater than 0, then we can say that AX gets temp. Otherwise, if it's less than 0, then we are going to set it to 0. How about that? Just as fake error checking that you would kind of do. Okay, and then we got to read in the Y. So for that, we can just do we consume the comma when we do get line? Well, it doesn't matter. We'll do another get line, but this time we'll say we go all the way to the next space. So we'll say it's expecting a space, which I think is a default. So, well, no, default is back a line feed. So yeah, we'll just say space. And okay, and then this one we can just read in directly. Okay. There's no reason for doing this. It's just kind of show you some different ways of doing things. Okay, we broke something here. In a, let's see where the error is. No matching function call for get line. Why? It's an is stream. Maybe it doesn't like the fact that this is not CN. I can try to cast it, see what happens, but so just to see, would it work with CN if we did CN like that? It would not work. Maybe I forgot how to the ordering of the parameters of getLine. Let me check. GetLine C++. Maybe getLine can only read a string. Maybe that's it. Yeah, it's a string. Okay, that's what it is. So getLine only reads the strings. So in this case, let's make this into a string. And so now let's go ahead and convert this into a integer. So for that, we can use the s2i function. And then for the second one, we have to read it into the temp again so that we can do the conversion. Or actually, we might be able to do it on the fly. Let's see if that works. I don't think it's gonna work, but let's try it. Yeah, it didn't work. Okay. It's okay, we can put it in temp. And then beneath here we can do a.y gets s2i of temp. And also, oh, we are already compiling with C++11, that's good. Okay. Oh, I forgot somewhere in E. Here we go. That didn't work. The on the fly conversion, you know. I guess that's because the parameter. Yeah. Oh well. Anyways, it's working now. So okay, so now we can do like again 9,47, and there we go. It is working fine. Now without the space, would it work fine? Nah, it needs a space. It like demands a space that will be coded this. That's okay though. If we get rid of that, I think it'll work in both scenarios. But now it requires a line feed. Oh, wait, compile again. So like 8, So yeah, so now it works fine, but will it work if there's a space? It will, but now we're forced to put everything on, we're forced to put each pair on its own line. So I guess it really depends on your source of input. I'm gonna go back and leave it to the space. Can you have multiple delimiters for getLine? It's a good question, if it was a question out there. I'm glad nobody asked it, because I'm not sure. I don't know if there's a way to put multiple ones. GetLine multiple delimiters. Can I use more delimiters for SQL? Stack Overflow. You can. Oh, you have to use a string for that, which we're not going to do that. So, anyways, but now we can see that this is actually a nice alternative to using this. Is we're doing this if we wanted to do something fancy. Okay. So both will work. The point of this is, of course, this is how you overload. Once you overload it, you have the freedom to do how you want to do your reading. It's up to you completely. Okay. So that takes care of that one. Okay, so now I said I wanted to do one with booleans. So let me do equality. That's a good one to do, actually. So yeah, let me just see if there's any peculiarities I have to worry about this. Nope, it's just kind of standard. Okay, so can we fit that one in here? You know, I think we can fit it in here. Let's just move the assignment operator. Oh, it's already beneath main. Perfect. That's perfect. Okay, cool. So we're gonna make it a member function for that one, because we can. So, I mean, I'm thinking, you know, we could do weird forms of equality, like between like integers and that. Yeah, let's do that. Not because it makes sense, but because you haven't seen a case like that. So yes, let us make a situation where you can say something like object of A is equal to like 2. Okay. Now you're like, what the heck does that mean? A is like an object with multiple variables. That's okay. We're gonna just like hard code that to say that it's always comparing it to the X variable, okay? Or to the Y variable, doesn't matter. Just to show you that you can do that. And then maybe we'll make another version that compares two objects. Okay, so we're gonna make 2 functions. We're gonna really overload the equality because we're doing multiples, okay? So typically when you're overloading the logical operators, they return booleans, basically. So because that's the logic, true, false, right? So Boolean, so you abbreviate with bool. In C, if you're recording in C, you just have to include I think the Boolean library, whereas C++ gives it to you automatically, or at least I think it does. So for that one, we're going to do. I was looking at an example with rectangle, so run rectangle there. So in this case, we're going to say it is a operator equality, and then make it a const because we don't need to modify the right side to this, but in this case, we are going to make it a integer. That. Passed by reference, maybe. Okay? Then the other one we're going to do is we are going to say between 2 objects of A. So const A, like that. Okay, so this one's going to be where we're doing something like A1 is equal to 5 or 6. And then this one's where like A1 is equal to A2. Okay, so that's the 2 that we're doing. We want it to work for both scenarios. And so let us go ahead and do, let's go ahead and do the normal one first, and then we'll do the weird one. So let's go ahead and do that one first. So this belongs to class A, and then we're gonna give this a name. We're gonna say it's the right side. And so what does it mean to compare 2 objects of A? Well, you got to start with a Boolean. So we're going to say bool answer, assume that it's not equal. We're going to set it to false. And then, or actually, no, let's assume that it's true. And then just kind of start checking and seeing if everything is equal. So we'll say like, if this, dereferencing. So here's the thing. This is actually good. Because right now, if Boolean operations worked with A1 and A2, they're probably comparing the pointer values versus the actual what they're pointing to. So yeah, this is an example where like you have to overload it if you're dealing with dynamic stuff. So this is actually pretty good. So because of that, I want to make sure we're comparing what they're pointing to. So we're comparing what like X is pointing to and what Y is pointing to. So that's why we're dereferencing like that. So we're saying if those 2 are equal to right X but dereferenced, then this would be okay. In fact, you know what? Let's just do this all in one line of code. If that's equal and that's equal, if all of that is true, then we're true. If it's false, it's false. So let's just say return that. So yeah, single line of code. Bam, done. So we're comparing the x's and we're comparing the y's. And then if this is true and this is true, true and true will return true. But if either of those is false, then this will return false. If both are false, then of course we're going to get false too. So this is a nice, easy way of doing that. So nice and clean way. I like that. Let's do the other one. So the other one is this one. So that's the weird one, just to show you that you can do that, because we haven't really done an example like that, where like we have different objects or different types. So in this one, we have an integer, which we'll call the right again. And so in this scenario, what we're comparing is, let's just do, well, technically speaking, if we did x, we wouldn't even need to make it a friend function. So yeah, let's do that. So you don't have to. So if this x is equal to the right, then this returns true. Otherwise, it returns false. So yeah, that's good to go. So because we're not accessing privates, technically speaking, I'm going to leave the line in here, but you don't need it here. And by the way, I forgot to write the word friend for both of these. Okay, so that's pretty much ready to go. So now let's go ahead and test it. But I guess first let's compile it, see if we have any typos. So must take exactly 2 arguments. Oh, it's because we made a friend. Why did I make it a friend function, actually? I should have just made it a member function. Actually, I did make a member function, so I don't know why I was thinking friends for a minute. I could have made it a friend function. So, yeah, I don't know what I was thinking there. Okay. Let's see. Constant must an argument of class enumerate type. Line 33. So that's probably just we're missing a semicolon somewhere. Yeah, right here. Okay, there we go. It was just a missing semicolon. All right, so it's working now. So first of all, let me get rid of the cin thing because I don't want to have to keep typing things in. Actually, no. That might actually be useful here, so we can test different inputs. So no, not really. What we'll do is this. We have objects A1 and A2 which are not equal right now. So if we say cout A1 equal A2, this should tell us false. But after we do this assignment, before we do the thing, this should tell us true. But then after this should tell us false again. Yes. So this should be true. Or sorry, false, true, false. Yeah, false, true, false. Let's see. Oh, is it because of that, actually? This is only couting here. Maybe I just need to put some parentheses. It doesn't like... It seemed to be trying to overload this when it's just returning a Boolean. So let me just do that. And maybe that'll get rid of that issue. Yeah, okay. It's trying to... Because we overloaded the operator, it's trying to overload and then do the equality. So here we go. False, true, false. We get zeros or ones instead of the word true and false. Just C++ works like that. Python will actually give you the word true and false. That's okay. But as we can see, first they're false because A1 and A2 are not equal. A1 has 2, 3. A2 has the defaults, which are 0, 0. So obviously they're not equal. But then we make them equal by assignment operator. So now it becomes a 1. That's cool. And then we go ahead and we change one of them. We change the X because we have deep copy. Then it's only changing the A2 and not the A1, which when we test again now goes back to being false. So that indeed proves that this code is correct. So hooray. Let's go ahead and test this weird one with the integer. So for that one, let us go ahead and put it at the end of the code. So let's say cout whether A2 is equal to 22, which should say it's true because we assigned that to 22. And then we can check whether A1 is equal to 22, which is not, because that one is still at 2, I think. So as you can see, true and false. So there you go. That's equality. Let's go ahead and do another one. Let's do pre and post increment, or one of those. So there's a lot of operators. We don't have time to go all over them. I recommend that you just kind of read the documentation on how to do each one. But let me just show you. So here, the trick about pre and post increment is that, remember how they actually work. Post increment first returns the old value of the class or of the type, and then increments it, right? So like if you have an int a and a has a 5, and then you say cout a++, the 5 gets printed out, but then a gets incremented to 6. So if you were to look at a afterwards, it would have 6 in it. That's post increment. Pre increment, which is like plus a, first you increase the a to 6, and then you cout it. So what you're couting is what's currently in a. That's the difference. And then decrement is the same thing. So when you're overloading those, you want to actually maintain that property. You don't want to mess with that. You actually can mess up that. So that's why it's a good idea to show them. So I really like this, to be able to keep going on this one. I think we can do it. Yeah, let's just keep here. So yeah. Okay, so let's go ahead and overload like maybe post increment and then like pre decrement or something like that. Okay, just so you can see both. And then it's the same thing for the other two. You just swap the pluses and the minuses. So we're going to make it as a member function. So what they return is going to be the same type that they are passed in, but incremented, I suppose. So we're going to say that a, is a return type. And then we are going to put the operator name, which is ++. And then we're going to put the parentheses. Okay? Although here, I don't want to do it in here because, again, space. So that's just going to be the function prototype. And then down here, we are going to go ahead and put that in. So we're going to say return type A, class type A, operator, ++ parentheses. And there we go. Okay. So basically, this one's the this one would be the pre-increment. So this one's, let me write that down here so make sure we know. So this is actually pre-increment. Okay, that one's the easy one because that one you just gotta increase it and then return it. So that's just a matter of increasing both values. So we're gonna say this. We don't need the this actually. We can just say x ++. But ooh. Can that work? Yeah, that should work. I think this has higher order of precedence than this. I'm not 100% sure though, but we'll find out. Yeah, and then just return the this pointer. Okay, so return the object itself. Yeah, okay, we'll find out which has higher. If this breaks, then it means that the other one has higher order of precedence. Well, we gotta call it, see what happens. So maybe we'll have one more a out afterwards here. But we'll do a2++. Wait, no, ++a2 because that's the one we just coded. That one. Okay. So let's see if this breaks down. Okay, so that breaks down. So I guess the ++ has higher order of precedence. So we need to do that. That's a neat thing I learned. I actually never had tried that, I guess. So I've never tried to do increment on a pointer. That's weird. I feel like I should have done that at some point, but maybe I just forgot. But yeah, so I guess order of precedence says that the reference operator has lower order of precedence than the increment operator, and so actually, you know what it is? I should have been using pre-increment because no, here it's okay to use that one. So yeah, no, so basically what it stands that the increment operator has lower order of precedence than the dereference operator. No, I said that backwards. Sorry. The increment operator has higher order of precedence than the dereference operator. So here, it was doing pointer arithmetic. It was first incrementing the address of x, so like the pointer address, it was incrementing it by 4 bytes if it's an integer, and then it was dereferencing it. So I was getting the wrong addresses. In fact, this was probably giving me the address of y, but then this was giving me some other address, which is why the thing seg faulted. So I fixed that by, of course, putting parentheses, Yeah. learn a new thing every day kind of thing. That's why I'm kind of glad running into these things because you learn. But anyways, as you can see, it worked. We go from 22 to 23, and we go from 3 to 4. Okay? But more importantly, I guess let's go ahead and do this inside of the cout statement. As you can see, the cout statement is printing indeed the incremented values, right? So I'll leave it like that. But the next thing I want to do is I want to do plus plus, right? This one should still print out the same thing as the line above it. But, well, right now it's just going to tell me that I haven't overloaded the operator probably. Yeah, so no operator declared for postfix. But the goal here is that I want to be able to print out the same thing. But then if I call cout again, I should see it has increased indeed, okay? So let us go ahead and do that one. That one is trickier. I actually have to remember because you have to pass in like some integer thing in the parameter. So I got to find an example of that. Let's see. Here we go. Aha. So it isn't intended. I remember correctly. I wasn't sure, but it is. So this is really weird, and this is why I like to show this operator, because like it shows you some weird messery that C++ likes to do. So for this one, the operator looks the same, but the way that you know it's post increment is that it actually has an int inside of it. I guess a parameter. That's weird. Like that's the only. I guess that was a way to work around the fact that like there was no other way to differentiate which was pre and post. Don't ask me why. That int is not even used at all in the function. It's just kind of there. It's like patching code. It's just kind of like, you know, no questions asked. It works. Don't touch it. Otherwise it'll break kind of thing. So yeah. We'll just call that the weird int, okay? Because that's all it really is. What does the documentation say about that? It literally probably says like, don't freaking touch this, otherwise you break it kind of thing, right? I don't know, with profanity probably. But yeah, no, I don't think any of the book explains as to the why that's there. But it's mostly like the reality is that it's there so that so that it can differentiate which one it is. I just don't know why they chose to do it that way. It's just. I mean, I see and I don't see the why. Like, I mean, I get it. They have the same operator for both, and they needed a way to differentiate the functions. So when you're overloading it, you're overloading the right, you know, or overwriting the right function. So, but you know, I don't know why they chose, for example, for the post to put the int, but not for the pre. Like, why did they choose this one? Why did they choose an int and not like a double or a float, you know, or a car? Like, why they chose the actual int? Like, I don't know. Somebody go find that and tell me on Discord. That actually would be cool to find out. But yeah. See, I'm curious, but not curious enough to Google it. So yeah. So anyways, what you want to do here is you want to make a temporary variable. Okay, so make a temporary a. Of course, for this to work, and this is why I wanted to do it here, so you got to make sure you already overloaded that assignment operator. Or in this case, I suppose it would be technically the copy assignment operator, right? We saw that. So I'm actually glad that we are doing it in this file, because otherwise this wouldn't work. So make a copy of that. We'll call this copy temp, and then go ahead and do the same thing as before. Increment your values on the object, and then go ahead and return not the this pointer, but return the temp copy, which has the old values in it. So basically what you do is you save the values, increment the new one, but return the old values back. Okay. And that way you maintain that sort of post-increment concept, okay? Yeah, so. And again, if this was pre and post decrement, just literally swap these two minuses. Like these two lines to minuses and these two lines to minuses, and of course, these two minuses. And then bam, you've overloaded that operator as well, okay? Well, assuming this works, but it should work. So, did it work? Let's see. Let's see where, okay, so we have cout A2, which has, this is too much stuff in here. So this one is printing out this 23, but this one's printing out 24. Okay, we have way too many things here. So let me go ahead and comment this one out. Okay, so as we can see, this printing is coming in from this line, from line 31, which indeed has the old value of 22 and 3 in it. And then I see out it again, even though I did the increment above. And as you can see, internally, it was indeed incremented. So this is working. It's just that when we add this extra print, it like gets confusing. So let's look at it carefully. So this is starting value, but then this is pre-increment. So because it's pre-increment, we do see the increased values in it. Okay. And then this line is coming from line 31, which is post-increment, which is still printing the old value, which is 23 and 4, but internally it has been increased. So when we print out again, we see the increase. So there we go. So it is working indeed for both cases, and everything is fine. World is great. So yeah, that's the pre and post increment. So I think that's all of the ones that you have to do for the assignments. Obviously, you have to do like or and, which is the same thing as the equality that I showed you, or addition and subtraction, and yeah, like pretty much you've seen all of them. So there are more things like the one we really didn't talk about is like the array one. That one's kind of weird. Just look at the documentation and go with it. But I don't think we really use that ever. If you were trying to make like a really fancy linked list, maybe when we do linked list, we can overload that one, and we can you don't know what linked lists are yet, but you will soon. You will, haha. But when we talk about linked lists, maybe when we build a linked list, we can overload the array one, so the square brackets, to be able to access it like if it was an array. That'll be a cool project. Yeah, we'll do that as an example in class. If somebody reminds me, which literally there's nobody in chat today, so like you might as well be talking to myself. So I mean, if there's no more people going to be talking, I might as well just record it on my, like myself and upload it, and not stream it since nobody's talking. So I might do that if I see like multiple days of nobody saying anything. So. Yeah, but okay. Like I said, I do have a video on operator overloading on Canvas already on YouTube from like previous semesters, where I pretty much go over most of the stuff that I did here with different examples probably. But yeah. So anyways, that's the end of operator overloading. So let's move on to exception handling. Exception handling is one of those kind of like we just kind of throw it into the group of things to do, but it's not really kind of useful, at least at this level, but it's good to know, I suppose. So what can I say about operator over exception handling? So right now, when you're error checking, your error checking mostly consists of if statements, and if something is wrong, you typically see out something like, yo, this went bad, we screwed up kind of thing. And then you either just have a print statement and then still run the bad code and then crash or whatever, but at least you have this print statement before you crash. Or if you're, trying to, if you know it's really bad and you just want to end it at that point, you can always like call the exit function or like return out of that bad function or something, right? So that's kind of the error handling that you've done so far. C++, however, provides you with additional tools to do error handling. The most important one of those being exceptions. And so what exceptions are they're sort of, they generate these objects that are thrown, and then you catch them somewhere else so that you can deal with the error. And this is mostly not, it's nice to write your own exception handling, but it's really meant as sort of a collaborative tool. So like if you're writing a class, like a standard template class, standard template STL, or like you're dealing with somebody else's code and whatnot, it's nice to have a standard. So the people that write these things, they came up and sort of created these exceptions. And so people all follow this sort of agreed upon sort of ordering of how exceptions are thrown. That way, you as a developer can catch those exceptions and you know exactly what they throw. Because imagine if like I was writing my own like library and I did my own form of exception handling with a bunch of if statements and like returns and things like that. as a developer, if I want to use your library, now I got to deal with all the weird code you wrote for exceptions, and like I don't even know, like, is it gonna give me an error that says like that is descriptive for like something, or is it just gonna say like, lol, it broke, good luck, fix it? You know, like you want to have some sort of standard so that everybody's on the same page and developing can go faster, right? And so if you go on Google and you look at different kinds of exceptions, you know, exception C++, I think I have a link on Canvas, you will see pretty much all the different kind of exceptions that are out there. There's like bad allocation and bad casting and things like that. So I'll post on the description below a link to that, but I'll also show it here. Here's one of them. There's a bunch of different websites. That's not actually the one that I was looking for. Let me see if I found the one that I'm looking for. It's different documentation one. CPP reference, maybe this is it. Yeah, this one, I think this one's it. So error handling, here we go. So I'll post both of them on YouTube in the description below. But you can see the different kind of exceptions that get thrown. So you can catch these exceptions and know what kind of, like, know more about the error so you can handle it, or at least you can kind of investigate further. So debugging is great, but this is more for like when it's beyond your hands and it's somebody else's code. Now, it doesn't mean that their code is wrong. It probably means you give them bad stuff in the first place. Like, you know, when your program crashes and it crashes because of using somebody else's library, odds are it crashed because you gave it bad stuff to the library. So the problem is yours, not people that made the library. But there are special exceptions. There have been situations where that has happened, but it's very rare. Okay, so don't go blaming other people for your code. So what I'm going to show you is basically a simple example of how to throw exceptions, okay, and how to catch them. And so for that, we need to talk about the try and catch block. Okay, so what is the try catch block? So when you're dealing with exceptions and you want to generate an exception, you go ahead and you use the throw command. So it's a special keyword in C++, and you would do it something like this: throw, and then something that you're throwing. So what can you throw? Anything. You can throw anything you want. In fact, the syntax for this is to throw an expression. Okay? And what can that be? Well, you could throw a variable. That variable can literally be like a built-in data type, like an int, a float, or whatever. It can also be a class. So like it could be our object of A that we were working with earlier. Or it can be a special class, like an exception class, which again, this is the kind of standard that people do. So when you look at the different exceptions of classes, you'll see that the most popular one is called exception. Okay? So remember polymorphism? You know, the idea of polymorphism, multiple forms, and you can achieve that by making a superclass that different classes are derived of after that. So like, for example, we have class A, and then we have class B inherited from class A, but we also have class C that inherits from class A. So if you have a function that throws a pointer of class A, we know that that pointer doesn't have to be just class A. Like, it could actually be pointing to an object of a derived class. So like class B or C, right? So if we add this format here, B or C like that, and we have a function that throws a pointer of A, we know that that pointer can actually be pointing to a B, to a C, or even to another A itself, right? And so what the C++ people did is they created this sort of superclass called exception. And this class, as one of the links says, is a base class for exceptions thrown by standard library components. Okay? So from there, everybody inherited this exception class with some basic things. I think the most important being there's a function called like what. So let me see. Here is I'll also post in the description below that exception example. But there's basically 4 functions. We have a constructor for it, a destructor that's virtual, which is useful. We have the assignment operator, because I guess that's kind of nice to know for overloading it. And this is the big one. It has a function called what. So it's virtual because we want to make sure that everybody, in fact, it's probably a pure virtual in exception. And then everybody else basically, actually, I don't know. Is it pure? I mean, if I was doing it, I would make it pure. But then again, me forcing developers to do stuff is never a good idea. So maybe I would just make it a virtual but not pure. So what it is it should return, if you call this function, it should return like an explanatory string, which hopefully explains what the error is and like how it came to be. Okay, so when you're looking at these documentation and you see, for example, one that says logic error, right? And if you call the what function, it's probably going to say exception class to indicate violation of logical preconditions. So if I click on that one, so here's an example of that one, and that one says that it returns. So it has additional functions that you can do, which you can then find out if those. So here's the thing: the classes that inherit from exception can have its own sort of extra parameters that are hopefully useful for debugging. So like once you know by calling the what function and seeing what the type of this really is, then you can downcast to the correct class that is inherited from exception, and then see that has any extra stuff. This one happens to have one that says other, so it has an other parameter, I guess. If I look at, like, let me see, maybe see this out of range one. Let's see if that has anything in it. Nope, that just has the same functions. But most of these seem to have the same functions, but you could technically add more functions, okay? And so that's pretty much how exception handling works. I go over more in detail in the summer. I'm not really going over it too much over now. I mean, I might talk about it a little bit next time, but you know, I'll give you the basic example. So you can say you start your try block, and the way you do your try block is like kind of like those little functions. So you start with try curly bracket. Then you got a bunch of statements here, whatever it is you're doing in your code. But then somewhere in here, you know, you might say something like if A is equal to null. Okay? So like maybe you have a null pointer exception or something. Okay? So if that is the case, then you know that you have an error because it shouldn't be null at this point. And then inside of the if statement, you can say throw. Well, I think throw is spelled with an H. You can say throw, and then you can make the exception. So I guess before you throw it, make the exception. So we'll call the E. So we'll say exception E. Now in this case, again, I'm just doing exception as a class, but you could do the derived classes depending on which exception it is, or you can make your own custom ones, which would mean you would have to make like a class here, you know, somewhere up here that says like class bad meme. Let's say that's the name of the error. And that is going to inherit from exception. And then we can overload. We can overwrite the what function with the right body, which says meme. I think it's a valid returning function, so you might have to say return the string, so like that. So maybe not the cout. And then you could write other functions, etc. Make sure you complete everything because the structure is virtual, so you might want to update that or whatever. But anyways, and the reason, by the way, the reason the structure is virtual is because if this exception class that you're making has any additional dynamic variables, then you got to make sure you deallocate them, right? And so you will do that by updating the destructor, and by being virtual, it'll be sure to call the right destructor. Similarly, because you might be passing this by value, you might need to overload the assignment operator to avoid shallow versus deep copy problems, right? So people thought about this ahead of time. They're smart. So anyways, you go ahead and you throw the exception. And so you finish your try block, and somewhere else in the code, before the code ends, you have to catch the exception. If you don't catch it, you will get an error when your program terminates. It won't terminate cleanly with return 0. It'll actually terminate saying like exception or something. Can't remember the exact. So you want to make sure you catch it. The way you catch it is you put in the catch keyword and you put in parameters, which is what you want to catch, essentially. So in this case, if you want to just make it a coverall, then you can just basically say exception E. But if you were throwing like an integer, you could put in there int and you would catch an int. Alternatively, if you really want to make it like a complete coverall, so you want to like literally catch anything that's thrown, you can use the 3 dots like this. So you catch, open parentheses, 3 dots together, no spaces in between, and then close it again. And this is literally like my catch-all. So like this is where you would say basically see out, you know, bad stuff happened. that you got to deal with. Alternatively here, if you're trying to catch this a specific exception, you can just catch a generic exception, or this is where you could also go ahead and catch like a bad meme, you know? Something like that. But more likely you want to just catch exception. Okay? And then here is where you would do what's called exception handling code, which is essentially what you want to do once you caught the exception. You want to see, you know, you might want to see out the value of what, see out some error analytics so that you can deal with it, and then terminate your program in a nicer way than just flat out crashing. So ultimately, exception handling is a tool to help you debug and to help avoid errors, but you really don't want to have exception handling code when it comes out to the customer because that looks very weird. So, like, you know, when your program crashes, when your video games crash, sometimes it'll say like bad allocation at this point or something, but most of the time it says like an error has occurred and then it closes. Sometimes they might say like, would you like to send this to the developer? That could actually be done with exception handling. Like you could do that as a catch and then send basically the information. Sure, but there are better ways of doing it than that. So this is more of like baby testing of exception handling, very basic stuff. So yeah, like I said, maybe we'll do some more next time. Otherwise, you can check out my video in the summer for exception handling, or just look at the documentation. But it's just basically, you're not learning something new here. It's just using what exists already from other people. Other things that I didn't talk about you might want to look at is how to use assert. Assert can be useful for checking like math errors. So go ahead on your own time if you're curious and look at the assert keyword in C++. That can be useful for error handling a little bit. I think that's it. That's pretty much it. If you have the DS Mallet book, you can look at it. It's chapter 13, I think. It has chapter 14, I think, which is it's the smallest chapter in the book. So I'm looking myself now and see if there's anything that I kind of want to point out. But I don't really see anything that else that is big. Oh, well, I guess if you don't know, since it's a member function, you do e.what. That's going to call the what function, you know, which again, I think typically returns the string, so you can just see out e.what or something there. But yeah, that's pretty much it. You know, assert can check whether expressions meet required conditions. Yeah, okay. So yeah, that's pretty much all I want to say. Are we going to learn to use debugging built into Visual Code 2? I know that has some built in. No, because that's something you kind of go over 135 or like on your own. Unfortunately, we don't have a standard set up for the debugging. Unfortunately, like we've been really trying really hard about that. Like, you know, for the longest time, I've been wanting to, and I even set it up, but then it just kind of nobody did anything with it. To set up like a virtual machine that has all the debugging tools installed, the compiler, everything, so that you don't even have to go into Sally. Like this is like Sally on a VM, and then it has extra stuff too. And then if everybody has that, then I can explain like this is how debugging works on this specific instance. But everybody's using different debugging tools, so like there isn't really much I can go over. But if you're curious more, in the summer I did go over debugging, and I explained the basic stuff like break, step into, step out of, and variable watch, breakpoints, not breakpoints. But it's all very trivial at the end of the day. You just kind of have to see it on your own. But you know, until we can figure out some standard that we all use. So yeah, which hopefully will happen someday. But I don't know. I made the VM and it just kind of nobody ever used it. It's just kind of lying there in its sadness. So yeah. But all right then. Well, I hope you guys have a good weekend. And next week we talk about templates and maybe some exception stuff if I can think of anything. But it's kind of one of those just like whatever. So yeah, after we talk about templates, we'll be pretty much done with all the C++ that we're teaching in 202. After that, it's just learning data structures, which will be the linked list stuff and recursion. So yeah, look forward to templates. See you all and have a good weekend.